One imagine a star so unimaginably large that if it replaced our sun, it would stretch far beyond the orbit of Saturn. For centuries, these cosmic giants have fascinated astronomers. But now, the largest star we know has started behaving in ways no one expected. Its light is changing. Its outer layers are erupting into space. And scientists are asking one unsettling question. Are we witnessing the final chapter of a stellar giant? The universe is home to hundreds of billions of stars. Some are smaller than our sun, while others are so enormous they challenge the limits of our imagination. Among them is Stephenson 2-18, one of the largest stars ever discovered. Located nearly 20,000 light-years away from Earth, this red hypergiant is estimated to be over 2,000 times wider than our sun. If this giant replaced our sun at the center of our solar system, its surface would extend beyond the orbit of Saturn. Every inner planet, including Mercury, Venus, Earth, and Mars, would be swallowed whole. Even light, traveling at nearly 300,000 kilometers per second, would take hours to circle this incredible star. It is not just big, it is almost beyond human imagination. So, what does it actually mean when scientists say this giant star is acting strangely? Unlike stable stars such as our sun, red hypergiants are incredibly unstable. Their outer layers are only weakly held together by gravity, making them prone to violent changes. Astronomers have observed that stars like Stephenson 2-18 can experience powerful pulsations, sudden changes in brightness, and enormous eruptions of gas and dust. Sometimes, they eject material equivalent to many times the mass of Earth into space. These events don't necessarily mean the star is about to explode. Instead, they reveal that the star is living through one of the most turbulent stages of its life. Every new observation helps scientists understand how the largest stars in the universe evolve, and how they eventually meet their spectacular end. No star can shine forever. Even the largest stars eventually run out of the nuclear fuel that keeps them alive. For millions of years, gravity and nuclear fusion remain in perfect balance. But once that fuel begins to disappear, everything changes. Gravity starts to win. The star's core collapses in a matter of seconds, unleashing an explosion so powerful that for a brief moment it can outshine an entire galaxy. This event is known as a supernova, one of the most energetic explosions in the universe. If a star as massive as Stephenson 2-18 reaches this stage, it could leave behind one of the most mysterious objects in existence: a black hole. The heavy elements created during these explosions, such as iron, gold, and uranium, are scattered across space, eventually becoming part of new stars, new planets, and even future forms of life. In a very real sense, the atoms in our own bodies were forged in ancient stars that lived and died billions of years ago. A supernova, powerful enough to outshine an entire galaxy, sounds terrifying. But would it actually threaten Earth? The answer is almost certainly no. Stephenson 2-18 lies roughly 20,000 light-years away from us. That means even if the star exploded today, the light from that explosion wouldn't reach Earth for about 20,000 years. Distance is the universe's greatest shield. Although the explosion would release an unimaginable amount of energy, it would spread across an enormous volume of space before reaching our solar system. To us, it would most likely appear as an incredibly bright new point of light in the night sky, an extraordinary event for astronomers, but not a catastrophe for life on Earth. Even so, scientists continue to monitor giant stars like this one. Every observation helps improve our understanding of how stars are born, evolve, and eventually die. As enormous as Stephenson 2-18 appears, astronomers don't believe we've discovered every giant star in the universe. The Milky Way alone contains hundreds of billions of stars, many hidden behind vast clouds of dust and gas. Beyond our galaxy lie trillions more galaxies, each filled with countless stellar giants waiting to be explored. Modern observatories continue scanning the cosmos with increasingly powerful instruments, revealing objects that were invisible just a few decades ago. It's entirely possible that somewhere in the darkness of space, an even larger star exists, one so distant that its light hasn't yet revealed its true nature to us. Every new discovery reminds us of a simple truth: the universe is far bigger, stranger, and more mysterious than we can imagine. The universe never stops surprising us. From the smallest particles to the largest stars ever discovered, every new observation reveals just how little we truly know. Stephenson 218 may be one of the greatest giants we've ever found, but its strange behavior is a reminder that even the most massive stars are not eternal. Somewhere in the vast darkness, another mystery is waiting to be discovered. And perhaps the next great discovery will completely change the way we understand our universe. Until then, we'll keep looking up. If you enjoyed this journey through the cosmos, don't forget to like the video, subscribe to the channel, and join us for the next adventure into the universe. Here's an even bigger mystery. If Stephenson 218 is nearly 20,000 light-years away, how can scientists possibly know what's happening on its surface? The answer is surprisingly elegant. They don't travel to the star, they study its light. Every star emits a unique pattern of light, almost like a cosmic fingerprint. By analyzing that light with powerful telescopes and spectrographs, astronomers can estimate a star's temperature, chemical composition, motion, and even detect whether it's expanding, contracting, or losing material. Tiny changes in brightness, color, and spectral lines reveal details that are invisible to the human eye. Piece by piece, these observations allow scientists to reconstruct the life story of a star that no spacecraft has ever visited. It's a reminder that some of humanity's greatest discoveries have come not from touching the stars, but from learning how to read the light they send across the universe.